Hello, I'm Professor von Schmohawk, and welcome to YU. In the last several lectures, we looked at some examples of binary relations. These binary relations can illustrate mathematical relationships or data measurements from the real world. In this lecture, we will introduce a special type of binary relation which we will often encounter in mathematics called a function. A function is a binary relation since it relates members of one set A to members of another set B. The difference is that although binary relations can associate any member of A with multiple members of B, functions cannot. In a function, each member of A can be associated with no more than a single member of B. A function can be thought of as a machine, which, when given a member of set A as input, produces one specific member of set B as output. Since there is only one possible output for any particular input, this machine is very predictable. Given the same input, a function must always produce exactly the same output. If we let x represent any input element, then the output element which function f produces from x is written as f followed by an x in parentheses. We call this f of x. So a function relates elements x from set A to elements f of x of set B. We say that the function maps elements of A to elements of B. This is sometimes indicated by writing f:(A) arrow B, indicating a mapping from set A to set B. Let's represent the elements in A and B as dots. For a particular function, not every element of A may be a permissible input. We call the set of elements of A which are valid inputs the domain of the function. Likewise, the set of elements of B which the function produces from these valid inputs is called the range of the function. So a function maps each element in its domain to exactly one element in its range. Every element of a function's domain and range will be involved in the function. Therefore, the domain and range are usually the sets of primary interest when discussing a function. Sometimes we don't know exactly what outputs will be produced by a given function, but we do know the general type of outputs which will be produced. In other words, we don't always know the exact range of the function, but we can describe a set which contains this range. For example, let's say we are studying a function which produces numbers as its output. We may not know exactly which numbers are produced, so we don't know the function's exact range. But if we know that they are all real numbers, we can say that the range is contained in R, the set of real numbers. The set which contains the range is called the codomain of the function, and so the range is always some subset of the codomain. For example, let's say that the domain contains Tarzan, Jane, and Boy, and the codomain contains types of fruit. We could create a function which relates each person in the domain to their favorite fruit in the codomain. For example, if each person had a different favorite fruit, then the range would be a subset of the codomain containing 3 fruits. Or if 2 people had the same favorite fruit, the range would be a subset containing 2 fruits. Or perhaps everyone had the same favorite fruit. Then the range would be a subset of the codomain containing only 1 fruit. In all 3 cases, each person is related to exactly 1 fruit, so these binary relations are all functions. On the other hand, if someone had 2 favorite fruits, then that relation would not be a function. To be a function, a binary relation must relate each element of its domain to exactly 1 element of its codomain. So a function is a rule that associates each element in its domain to exactly one element in its codomain. There can be additional elements in the codomain which are not associated with any element in the domain, but the subset of elements which are associated is the range of the function. The range can be as small as a single element or could include every element of the codomain. Like any binary relation, functions can be represented as sets of ordered pairs. The set of ordered pairs which represents a function is sometimes referred to as the graph of the function. Since a function's domain and range can contain any type of elements, the ordered pairs in its graph can be pairs of any type of elements. However, in algebra, a function's domain and range are typically sets of real numbers. Therefore, its graph will be ordered pairs of real numbers, which can be represented as points on the Cartesian plane. In the next lecture, we will take a closer look at these numeric functions and their graphical representations.